So we have a problem here that says write an inequality for the graph below. And we notice that there is a vertical dashed line at x equals 2, and everything to the right is shaded in. So we need to refer back to our linear equations. When we have linear equations, vertical and horizontal lines are expressed as follows. If you have x equals some value or some constant, let's say 2, then you have a vertical line at x equals 2. So at x equals 2, you would have a vertical line. This is talking about linear equations. If you had y equals 2, then you would have a horizontal line at y equals 2. So at the point y equals 2, you would have a horizontal line across. Obviously, we're dealing with inequalities, but we want to refer back to this information. So the other thing that we want to remember when dealing with inequalities is that you have a less than sign, greater than sign, less than or equal to, or greater than or equal to. And depending on the sign, whatever the sign is, it tells us what kind of line we will have, whether it's a dashed line or a solid line. Here we see a dashed line, which tells us that the line itself is not included in the solutions. So everything that is greater than this line in terms of an x value is included in the solutions. So if we were working with equalities or equations, we would see x equals 2. However, it is an inequality. On this graph, we see that for any y value that we have, for example, if y equals 1, we come over and see what the solutions are. We notice that 2 is not included, so we would have an open circle here, but everything to the right of 2 is included. Everything greater than 2 at y equals 1. At y equals 2, we look and we see that 2 is not included, the x value 2, but everything greater than 2 is included. Thus the shaded area. And you could go on for each of the y values, and you would get the same answer. Thus, when we write the inequality that x must be greater than 2, we see that for any y value, we can read this, for any y value, x is going to be greater than 2. And you can check that. You can check the solutions. And it's the same way that we figured it out. If you go to any y value, 3, you look to see the solutions. Is it larger than 2? All of these are solutions. So if you check any random point inside the solution box, for example 5, and here 2, at the y value of 2, does the x value of 5 make this statement true? Then 5 is greater than 2, that is true.